Hi, welcome to this tutorial in which we're going to look at some questions and try to apply the rule of division, the law of division, which I've written for you in the top right hand corner. You might like to pause, have a go at the questions and come back and see how you've got on. The first one is quite straightforward. It's y to the power of 8 minus 3, which is 5. Okay? The second one I've written in this form on purpose. My suggestion is that you write it as a fraction and then simplify it. You can see that 4 will go into 4 once and 4 into 25 times, so there'll be 5 in it. And y to the power of 5 divided by y to the power of 4 will give us y to the power of 5 minus 4 is 1. And the simplest form is 5y. This next one is a bit more involved. Hopefully you can see that the 6 will cancel with the 12. 6 into 6 is once, into 12 is twice, so there'll be a half in it. And a to the power of 4 divided by a cubed, 4 minus 3 is 1. We just write a on its own. And b to the power of 6 divided by b to the power of 4, 6 minus 4 is 2, so there's a b squared in it. And you can see there's a c on its own at the bottom, so we just write it like that. Of course, it's not very neat, so we write it as ab squared over 2c. There is an alternative answer. If you got an answer of ab squared c to the minus 1 divided by 2, it's also acceptable. They're equal to each other. And when we do negative indices, you'll be able to see more clearly why. Well, I hope you got on well with these three. The next ones, the first one is a bit more challenging. You might want to pause and then have a go and come back and have a look to see how you've done. The first one is probably the most challenging because it involves exponents raised to exponents. So we need to use this rule here. A to the power of m to the power of n is a to the power of m times n. Well, the power of the 2 here is a 1, and 1 times 5 is 5, so it's 2 to the power of 5. I hope that you didn't think it was 2 times 5, which is 10. That would be incorrect, but that's a very common error that people make. A to the power of a half raised to the power of 5. A half of 5 is 2.5, or if you like, 5 halves is 2.5, or 5 over 2, whichever you prefer, all divided by 8a cubed. And that 2 to the power of 5 is 32. A to the power of 2.5 divided by 8a cubed. We can see that 8 will go into 8 once, into 32 4 times. So there'll be a 4 in it. And a to the 2.5 divided by a cubed, 2.5 minus 3 is negative 0.5. You can write a fraction, a half if you prefer, negative a half. Both okay. It's a matter of preference. Okay? That was challenging. I wonder how you got on with that. I hope you did well. This next one, 2 minus 2 is 0. A to the 0 is 1. If you remember the last tutorial, at the end of it, I brought in a to the 0, or x to the 0 is 1, as long as this a is not 0. Now, if you write it out in full, you can see you've got a times a in the numerator and a times a in the denominator, and these a's will cancel each other out to leave you 1 over 1, which is 1. This next one, the power in the numerator is 1. 1 minus 2 is negative 1. But if you were to write it out in full, then you can see that one of the y's will cancel to leave you 1 over y times 1, which is y. And these two answers are equal to each other. They're both acceptable. But you will see when we do negative indices very soon why it's the same answer. Okay, this next one, if you're multiplying fractions, you can cancel whatever cancels, or you can multiply the numerator, which is what I suggest, simplify the top, and multiply the denominator. So you get 4x to the power of 5 c y to the power of 4 divided by 8x cubed c y to the power of 5. I've lined them up so it's easier to see. 4 will go into 4 once, into 8 twice, so we'll get a half in it. And x to the power of 5 divided by x cubed is x squared. 5 minus 3 is 2. You can see those c's cancel out nicely, so they've gone. And y to the power of 4 divided by y to the power of 5 is y to the negative 1. Or you can write it as x squared y to the negative 1 divided by 2. If you've got a different answer, if you've got this answer here, x squared over 2y, it is also acceptable. And again, when we do negative indices, you'll be able to see why. But just to point out very quickly, you can see here that there are 4 y's at the top being multiplied by each other, and 5 at the bottom being multiplied by each other. If you cancel them down, you'll see there'll be y left at the bottom. And just to point out again the c cancelling, you could have said, oh, it's c to the 1, divided by c to the 1 is c to the 0, which is 1. Okay? Well, I hope you found that useful. On to the next one. Take care. Thanks for listening.